Welcome. My name is Travis Altman, and I'm here to discuss reverse engineering an obfuscated .NET application. First, I wanted to give a huge thanks to Curtis Meckling. I work with Curtis, and we worked together on both going through the process of looking at an application that was obfuscated and didn't want you to see the code. So I really leaned a lot on Curtis to try and figure out how the best approach to go about looking at an application and breaking it apart and figuring out the functionality and seeing that through the obfuscated code. So I just want to take a huge thanks to him. So the outline is basically this. So this discussion is for all audiences. You can have either no experience or be a seasoned .NET developer. Hopefully we'll go over some of the basics initially. That brings everybody up to speed. We'll get that out of the way, and then we'll start discussing more complex ways to look at a .NET application, especially one that's been obfuscated. And we'll see how to go through that process. Also, I'll be demoing this application and how you go about reversing something that's being obfuscated. So here are the basic 5 steps to reverse a .NET app. First, you want to run the application. You have to run it to be able to understand it and see how it works and what is it trying to do and how do you what's the functionality that you want to extract or figure out. Second thing you'll do is decompile the application, and I'll go over how we do that. It's fairly simple. Then once you do that, you can review source code, because that's what the decompilation process does. It gives you source code, and then from there you can try and hone in on the functionality you're looking for. You know, is it input you're interested in? Is it some sort of math you're interested in? So things like that. Now, if the application is obfuscated, you want to look for certain key constructs within that obfuscated code, and hopefully by looking at those certain constructs, you'll be able to kind of figure out where that functionality lies. And optionally, you can modify the app to achieve some desired functionality. So I'll go over that process as well. So this topic isn't new. Many others before me have done this and discussed about the hidden features or insecurities of the .NET applications. Here are just a few to name them, but they all have discussed in the past about what I'm talking about today. So props to them. I learned a lot from looking at these guys and seeing how they went about it, and this is just sort of my take on it. So reversing and obfuscation. What are these two? So reversing basically is when you're giving an executable and somebody says, hey, I want you to figure out how this executable does what it does. And basically that's it. So you're almost starting with your hands tied or you're blindfolded, and you're trying to figure out, okay, how do I extract this functionality from what was built into this executable? That's sort of what we're talking about today when it relates to reversing. And obfuscation simply means hiding. And we'll I'll just go ahead and say now that it's not necessarily encryption. It could be an encoding, or it could just be somebody's logic that tries to scramble stuff. So that's the general term for obfuscation. So let's go over some of the basics of .NET and its applications. As Microsoft puts it, and a lot of people put it, it's a framework. So, and I sort of hate that term because it's just a general statement. It doesn't really tell you exactly what it is. But at the end of the day, it's a blanket term for a family of Microsoft technologies. And just maybe kind of leave it at that. But what I want to straighten out today, though, is most people think of .NET, they think of web. In this talk, we're not talking about that. We're talking about standalone executables that get executed on your device, laptop, desktop, whatever it may be. And in this particular case, we're going to be talking about C#, written in .NET, but it could be any language that goes through the .NET framework. So for .NET, you'll have a standalone executable that's built for .NET, which will run inside the application virtual machine. If you start reading some articles, you may also see it referred to as the CLR, which is a Common Language Runtime. That's what Microsoft calls their application virtual machine. This also applies for Java. They call theirs the Java Virtual Machine, or the JVM. So Windows just calls it CLR. But the .NET application virtual machine is required for all .NET executables. And here I just show a quick screenshot. Sometimes you go to run an executable, you may get a pop-up that says, "Hey, no, you got to have .NET to run this application." So I'll briefly talk about executables. There are essentially two main kinds of executables: compiled and interpreted. Compiled applications you can kind of think of as you'll usually have to do the next install process. Not always, but it's just in general, when you think about compiled applications, that's what you think about. Although a compiled application could be standalone, you don't necessarily need a next. But that's what, when people think about compiled applications, typically it's probably something like that. Interpreted applications have to have a virtual machine. So both Java and .NET, which are interpreted languages, have to have that VM to run the executable. So to do any of this stuff, you'll have to install the virtual machine. So you'll have to install the .NET framework in this case. Now, compiled executables are often built with a higher programming language, such as C++, which a lot of people have heard of. This thing is translated to a lower language known as assembly machine language. And due to the nature of compiled executables, they're much harder to reverse back to original source code, or they're much harder to figure out the functionality of that executable. There are a number of reasons for this. First of all, there's different architectures. So there's x86, there's PowerPC, there's MIPS, there's ARM, there's all these different architectures for which applications can be compiled for. Then you have different compilers, right? You have GCC and WinGW and Microsoft's Visual Studio. So you have all these different compilers which add their own little differences when you're doing that. So it's difficult to do that. Interpreted languages, though, are a lot easier to reverse. So basically, the interpreted compilation, sometimes referred to as JIT, or just-in-time process, is more structured, okay, and it retains more information, or really the compiled executable has to have a lot of information to be able to run inside that virtual machine. So by nature of it, interpreted executables have to have a lot more information about how it's going to be ran. And they all go through the VM, so it's a common environment. So it's not different architectures here. It's not different compilers. It's one compiler. Now, yeah, that compiler can sit on different architectures, but it's meant to run the same way every single time. So getting the source code is trivial, essentially. And I just want to stress that if you have an interpreted application, getting the source code is nearly trivial. Because of this trivial way of getting source code from an interpreted application, developers will obfuscate their code in the hopes that it will be much harder for somebody who gets a hold of their code to reverse that and basically negate all their hard work that they put into the application. There are a number of tools that will obfuscate your .NET application, and most of these obfuscators are simply going to hide, or at least in my experience, they're simply going to hide things such as variable names, class names. They pretty much hide anything to some extent that's user defined. If you're defining it, then it's going to obfuscate it. That's typically how you see most of these obfuscators work. Now, the first thing you'll need to do is determine if it's a .NET application or if it's something else. There are a number of ways to do that. The tool I think that is hands down the best is one called CFF Explorer. So you install it on your Windows machine and just get it up and running, and then all you have to do is they have a right-click context menu. So right-click on an executable, and you can pull up information about it. Here I'll just show you an example. So I right-click, I found Firefox, and I right-clicked on Firefox, and I said, hey, open with CFF Explorer. And here you can see, first of all, CFF Explorer has a lot of nice features. I'm simply going to scrape some of the nice features it has right here, but basically you'll see some properties of the executable. First thing you'll see is the path, but you'll also see the file type and file info. Here we see that it's a portable executable 32, and you'll see that term used commonly. Most Windows executables are called PE or portable executables. In the file info, you'll see basically what was used to compile this application. So in this case, it's the Microsoft Visual C++ 8. So here's this application called Guess Password, which is just a simply little application I wrote, just a demo for this purpose. All it does is checks your password to see if it's true or false, and then allows you to get past one screen if you enter the correct password. And I'll maybe kind of keep continuing to use this as an example. But here I did the same thing for Guess Password. I did a right click, and in CFF Explorer, here you see it says it is a portable executable 32, but it's a .NET assembly. So right off the bat, we know, all right, it's .NET. So now we can use our reversing .NET tools to then progress forward. So now the next step is to decompile. There are a couple tools that I like to use to decompile. One is Reflector, and the next one is ILSpy. Thing to keep in mind is Reflector is a paid application, and ILSpy is a free application. But Reflector does have a 30-day trial, and it does have some extra features, which I'm going to be going over, that make it probably more so the tool to use. Although there is times when I love to use ILSpy because I feel like it has a more friendly interface and it tends to show the code better. But more to come on that. So here I just wanted to show a quick screenshot of ILSpy. Here I've highlighted the guess password, and it just kind of shows you sort of a tree structure of the application. And basically these tree structure is just code blocks. It breaks down code blocks typically into classes. So, and we'll do the same thing for Reflector. Same thing. You'll see that these two tools almost mirror each other, and I bet that before you know it, ILSpy will have a lot of the same features and functionality that Reflector does. So you can see on the right hand side, you start calling your classes. I want to go over some tips for decompilation. So when you throw an executable into either ILSpy or Reflector, you're going to see other things besides the executable. These are simply dependencies or the libraries that the executable calls in, and the decompilation tool will have to bring these in. So basically just ignore everything else except for what you're looking at. Also, you want to focus on the real code. And basically what the real code is sort of all the functionality that for the most part you have defined, or all the functionality you've written into the application. A lot of the stuff is simply building up the application. What the let's say, like when people develop in the Visual Studio, and it's sort of all the other little things, the foundation that you use. That's simply what gets built into the application. And so the blue boxes and stuff are things that kind of get built automatically inside the IDE. So basically you want to look at the pink bricks. That's where all the real code is. So here's the application we're going to look at today. It's one called Safe as Houses. And this is a real application that I went and downloaded from download.com. And I wanted to see if I could find an application of where I could, sort of demonstrate breaking some functionality. And I just happened to stumble upon this one, and it seemed like a good example. So what it does is it is a password keeper. So mainly it's one location to keep all your passwords. There's other applications like this as well. This happens to be just one that was written in .NET. So let's go ahead and open up Safe as Houses in ILSpy. That's one of our first tasks, right? So you'll see here that, and I wanted to highlight guest password up top and Safe as Houses down below. So once you open the tree structure of both and the guest password, you can see that I have form 1 and program. These are the names that were applied to these classes. Down below, Save as Houses, all of a sudden, you don't even see the name of the application. So Save as Houses is removed. It's just a hyphen. And then all the other code blocks below are missing descriptors. There's nothing there. So immediately we see signs of obfuscation. Basically, I'm just speaking to the slide before going over that screenshot. So now let's dig a little deeper into each one of these and compare. So here's guest password. So I've highlighted the form 1 class, and you can see here it has certain things. You can see it's defining buttons, it's defining text boxes. It has, the actual form, window form that it's pulling in. I got, button clicks. So these are all the classes that are getting defined within this class. And everything's nice and neat, and you'll typically see. So take the third private there. You see private text box 1, where text box 1, same thing for button 1, is a user-defined variable or a user-defined string. Nice, so keep that in mind as we look on the next slide here. So here's Safe as Houses. Just without even knowing a lot, you can already see where these gray boxes, where the STX, the ETX, and the ... dots are all blocking some code functionality, and you don't know exactly what they're trying to block. So once again, you have the third line and the second line with the second and third private. You have private button, private text box. Next to that would have been a user-defined text box or a user-defined button, whatever you named it. But here we see it's obfuscated. They're blocking it. So we can't really follow the logic completely because we don't know what these variable names are called. So it's difficult to follow the code. And that's the goal of obfuscation, is sort of to, slow me down the way I'm trying to figure out how things work. So this basically just goes and it speaks back to the slide before. So just keep in mind that anytime you see those gray boxes, the STX, the ETX, those are clear signs of obfuscation. So now, the first thing I talked about was that you want to run the application and understand the application. This to me is probably the most important part. Because if you don't understand what you're trying to achieve or what you're trying to look for or the holes you want to expose, you won't know what to look for. So that really is the first part and one of the most important ones. So here, if we run the application, this is the login page that we'll get. It simply asks for a password. Now, If we authenticate with the correct password, we are granted access to the application. This is sort of a quick screenshot of what it looks like up top. But however, if we supply an incorrect password, we're going to get the password incorrect window pop up at us. And if you click on OK here, the application will close. So it's just like, all right, you didn't give me the right password, I'm going to close. Then you have to open the application again in order to enter your password. So items of interest. So I know that was only a little bit of functionality there, but those things are going to what we want to do. Those things are the things we're going to take a look at. So the first one, the application asks for input. Okay. What is the code going to look like that takes that input? Something to keep in mind. Number two, an incorrect password presents a pop-up stating password incorrect. Okay, that's easy. How do we find that phrase password incorrect somewhere in our code? Or how does it make that pop up present to you? Those are things we want to take a look at. Number three, the application exits after you click OK when your password is incorrect. Okay, how does it do that? How does it close the application? Okay, what would that code look like, and where can we find it? And number four, a successful authentication brings up another window. Okay, how does it do that? How does it go from one window to the next? Okay, how does it check for that authentication? Maybe there's some strings on the second window that we could probably look for. Things like that. Those are the things you have to keep in mind when you're combing through the application. So the main idea is just take those certain areas of interest and you want to find that functionality. And even if the application is obfuscated, hopefully you can keep those code blocks or those constructs in mind, and hopefully we can make sense, even of obfuscated code, what that code block or what that construct would look like when we go and look for these things. And I've talked about 4 here, but we could easily focus on other things. I just wanted to take this initial authentication login piece and kind of go over that. So now you want to search for items of interest. You know, say 4 things you want to look for. So how do we go about searching for them? Number of ways to do this. I'll highlight just 2 of them. One is to decompile all the code into one text file. All right. And the second one is to use the Reflector plugin called Code Search. I'll kind of talk about pros and cons of both here. So to decompile code into text file, simply select the executable inside your decompiler. And in this case, I'm talking about Reflector. I've done this in Reflector, and I'll do most of my exercises in Reflector. So you right-click on that executable, and you say, hey, I just want to save code. Then you'll save it as a C# single file. This is the approach that I like the best. I want to get all the code in one single text file. And so you do it that way. So now you've got one single text file, and you can use your favorite text editor to search through the decompiled code. Now this is very handy to have. You can sort of, take a quick peek and see what you're working with. The disadvantage to that is you're searching through a flat file, and it doesn't really present a lot of context. And by that I mean, if you're in Reflector or even in IDE, typically you have, code chunks or blocks or classes, right? The IDE and say the decompilers will sort of give you that context and keep that code chunked together. Towards a flat file may not always do that. So on the other hand, it's always handy to have a raw dump. And I'm a big fan of text files, ASCII text, and then you can also keep that for historical purposes. So if you're saving, all this information for later, you can have everything in one area and like, all right, I don't need an IDE, I don't need a decompiler. I went ahead and I've got all my text in one, or my code in one spot. So, and the second approach, which is probably the most handy, is Reflector has a plugin called Code Search. And it's very convenient because it's already in Reflector. It's already in your decompilation tool. So it's right there. You don't have to switch to another application. And also, you're not going to lose context with code search. So all that functionality and all that code blocking is going to stay intact. So you don't have to lose sort of that the constructs and how they'll look. So using code search, we'll search for all 4 items of interest. Okay. And here's simply the link to that plugin. So keep in mind the 4 items of interest. Ask for input, pop-up password incorrect, exits the application, successful authentication brings up another window. So if the application asks for input, okay, one popular way is through the textbox class, where the convention is this.textbox.1 or 1.text. And here, textbox1, when I've kind of talked about it, is a variable name, and it's user defined. And most obfuscators are going to hide this. They'll leave the this in the text, but whatever you define it as, they're going to hide that. So your methods may vary, but you could do things like I'm going to search for this .star.text inside code search, or you can just do a search for maybe star.text or this .star. Depends on how much of that is in the code itself, and it can be annoying. So here, I went ahead and so up top is basically a screenshot of what it looks like. So you can see here that I'm searching for this .star.text. And here's where the nice context has. So for each code block, it'll tell you, okay, here is the code block on the left, or the path on the left. And then here's the hit count for each one of those code blocks. And I've cut this off for brevity because there's more results below. But here you can see, like, okay, I've got 32 hits in one, 574. You know, it's not like popping out at me. I don't necessarily see maybe that functionality right off the bat. So on to the next piece. The second one was that it pops up a message saying password incorrect. So a pop-up box is typically done through messagebox.show method. And this is given 2 arguments, the window title and the window message. So you will see it like messagebox.show. First one is title, second one is message. So we can use code search to see how many message boxes are in the application. Hopefully this will sort of narrow it down. So go into code search, search again, and once again I've cut the results off for brevity. But now we can see there's less hit counts per code block or per path here. So it's starting to get a little better. But right now it's not obvious where that code, where that functionality resides inside the application. So we also talked about where it pops up that message that says password incorrect. Now that term password incorrect has to be in the code somewhere. It has to be. Okay. So you can just search for it in code search, all right? But there's no results. So no dice. And we knew it already, but that just goes to show you, you know for sure a lot of that functionality is hidden via obfuscation. So the application closes. That was the third one, right? So how does it do that? And remember, if you incorrect password, okay, it's going to bomb out. So once again, there are a number of ways to handle this with inside.net. 2 of the more popular ways are application.exit and environment.exit. So we'll need to search for these as well. Here I'm showing results from environment.exit. Once again, I cut it off for brevity, but there weren't that many more hits beyond that. We're starting to get more and more narrow focus here from our search results. So getting a little better, but now, and once again, at this point, you know, you can go ahead and start clicking on each code block in the results here, and then in the upper window, it'll show you the code, the decompile code up above, even though it's obfuscated. So you can I'll go ahead and start looking through the code at this point if you want to. But let's keep searching. So the successful authentication opens up another window. Okay, this is the fourth and final thing we're going to take a look at. And I know I keep saying this is a popular way to do things inside .NET. Of course, any developer can write code to do whatever they want for the most part. You don't have to use the popular methods inside of a framework like .NET. You could roll your own. But most developers are going to take the easy route and use these established methods and classes and functionality. So, but for this case, the two of the main ones are window.show and window.hide methods, and they're used in tandem. And even though they're commonly used in tandem, it's still a good idea to search for both terms when you're trying to dig through the application and figure out the functionality. So here I just did a search for hide with the parentheses, and now there's only 3 hits. So now we're money. We've narrowed it down to 3 hits. Just go click, 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 review those 3 blocks of code. Which one of those 3 blocks of code is our functionality we're searching for? Or maybe it relies in all 3. Maybe it's broken up into those 3 blocks of code. So the code search plugin. Using this plugin, you can narrow down to what you're looking for. Here we've gotten into 3 locations, and this is, we figured, all right, between this is probably where our functionality lies. And you're just going to click on each one to view the obfuscated code. And once you do, don't forget the other constructs we were looking for, right? Environment exit, startup text, message box that show. That functionality, okay, and that obfuscated code should probably lie somewhere within those other search results as well. So we want to keep that in mind as we're looking at it. So we want to make sure that that functionality is in the environment exit, message box. All that should be near each other inside the functionality that we're looking for. And another thing to keep in mind is that code search is case sensitive. So that's one thing to keep in mind as you're searching through code. So the first hit, we found the functionality in this particular case. So here you can, I may speak to it. Yeah. So excuse me. Here I'll show the same code in ILSpy, and this is where I like ILSpy. I think it does a better job in showing code. And here on the left-hand side of the yellow block, I've kind of got the line number so we can kind of go over it. So I'm going to kind of go back and forth between these 2 slides here. So on line 6, the developer is assigning a variable a to whatever you type into the text box. You'll see here it says string a equals whatever this dot whatever dot text. He's assigning whatever you type into the form to the variable a. Line 7 is the if statement is comparing the password values. So it's saying, hey, if a equals to this, then we're going to go down into this code block if those do equal each other. So line 17 says if the password is correct, base.hide will hide the login box. Remember we talked about how you hide one window and then show another. Oops. So line 17, base.hide. So we're seeing the functionality that and then you see the blunt.show. All right, so we're starting to see that functionality that we were looking for earlier. Line 22, the message box that tells you your password is incorrect. So line 22, message box that show, and here we talked about how password incorrect could not be found within this code, and here you see the reason why. It's totally obfuscated. We don't know exactly what that is, but we know it's not password incorrect. And you see here it has one part comma, second part, so it has 2 arguments. We definitely know this is probably what we're looking for. And then next line, line 23, is the environment exit we talked about. So we're starting to see a lot of the functionality that we knew existed in the code somewhere. And now we see exactly what's going on. So at this point, we want to break authentication. We want to subvert this. There's a couple ways, and the functionality or the end goal for me is I wanted to bypass that authentication, right? I didn't want to have to give a password, or let's just say I had gotten this off somebody else's device. I wanted to take that executable and not have to know their password to be able to gain their passwords. Okay, that's the idea that I was going over. So there are a couple tools that will allow us to modify executables. One is Grey Wolf, and the other one is Reflexel. And I'm really going to go over Reflexel for the most part, or I am going to go over Reflexel. So here's just a screenshot of what Reflexel sort of looks like. Then it's the bottom half. The upper half is the code you're looking at. The bottom half is the Reflexel tool itself. So with Reflexel, we can edit executables. So we can take instructions within the executable and change those to whatever we like. And these instructions are referred to as CIL, or the Common Intermediate Language. And CIL is the lower level language used by the .NET application virtual machine. So we talked about how you have C++, which has machine language. This is similar in the .NET environment, right? So you need some type of lower level language, and that's what the .NET framework or the VM expects for a .NET application. So you have a higher level programming language such as C#, and that is then going to get converted to CIL. Sometimes it's referred to as just IL. Now these CIL instructions, just like Java, are going to be JIT, just-in-time compiled into native machine code at runtime. And they have opcodes, which I'm going to talk about. They're at the heart of the CIL and tell the application what to do. It's not that important, to necessarily understand all the ins and outs of CIL. Once you get going, you can sort of Google search and figure your way out. It's not really that hard to deal with, especially because when you are looking at CIL, you'll have source code, or even if it's obfuscated, you'll have it right there with you, and it'll be easier to follow the flow of the CIL. So in this example, I'm just showing the first 3 lines of the save as houses, and we already see that we have window form text box, looking at string, accepting strings and forms. So we already see some of that functionality coming through, and we can compare that to the source code or the decompile code above. So modifying CIL is fairly straightforward. When we look through the code and then the CIL, we see an interesting instruction on line 7. The operand to the instruction is op equality. This is what compares the passwords. Okay, the next opcode in that instructions is on line 8 is BR false. This stands for branch of false. Okay, so here what we want to do is change that value to true. You'll also notice that the operand for the opcode on line 8 is arrow 36. This means it'll branch to line 36 if the password doesn't match. Okay, this branches all the way down to the message box functionality, and to break this functionality, we can just change, like I said, from BR false to BR true. So you go on line 8, you can right-click, edit inside of Reflexel, and change the opcode from BR false to BR true, and then update it. And at this point, what's going to happen is if you feed it an incorrect password, you will be authenticated. If you feed it a correct password, you will actually be closed out of the application. So, and then you need to save it out. So after you've made the change, you simply right-click on the executable inside of Reflector, go to Reflexel, and just do save as. And so I can't remember if I mentioned or not, but Reflexel is a plugin to Reflector. So once again, Reflector is your one-stop shop for reversing .NET applications. So now you have a patch executable. So we'll go ahead and demo that. So here we can see password safe right here. I'm going to go ahead and drill into that. So now up here is the code that we've talked about, that we've seen in the past, and I've shown screenshots of. So here we're at the functionality that we want to change. And you can see here of the system windows forms text box that we saw earlier. I've already got it up, but once you get the tool installed, you simply go to Tools and click on Reflexel, and it opens up this lower pane here in Reflector. So now we see the BR faults that we were talking about here before, and the jump to line 36. So now we just want to right click, edit, change BR faults to BR true, update. After we've done that, come Reflexel, save as, and it's going to name it as a safe house or whatever the executable is called .patched. I typically leave it as that. It's the safest way to go. You're keeping your original executable, although in this case you can simply go and download it again. Here it says can be replaced. I'll go ahead and do that. Now what I can do is go back to this right here, this executable. Well, first let me just go through, just show you, well, here my password is, this is the original, the unmodified, is monkey. So M-O-N-K-E-Y, monkey, and I get authenticated to the application. However, if I come here and I monkey bang on the keyboard, I get incorrect. And that closes. Now, open up the patch version, I type in monkey, I get incorrect. Open it again, I monkey bang on the keyboard, I get authenticated. So once again, we have subverted authentication. Simple as changing from false to true. We've gotten authentication to this application. Here I only have one entry of test, 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 but had this been a real user's passwords, you would have their, all the passwords they keep inside this safe. So that was fairly straightforward. You can see how easy that was. So now you've patched it. And we run it, we give it incorrect password, we get authentication. But we don't have to stop there. We can delete chunks of code that remove functionality altogether. Here's another screenshot of that code. What we can do is just completely remove that if statement. So don't even check for a password. Just give us access to the application. Okay. Here we can delete lines 1 through 28, save the patch application, run it again. Now it won't matter whether you feed it an incorrect password or a correct password, it's going to give us authentication to the application. So we'll go ahead and try that. So we've modified this. So let's close this and open it back up. So here's the original. Now we see this is back to the original of BR faults. So I need to delete lines 1 through 28. Just do a shift click. Oh, try that again. delete. Once again, after we've done that, go ahead and save that out. I'll go ahead and keep it as that. Replace. Now I'll open the patched. Monkey bang. I'm in. And if I type monkey, I'm as well. So no matter what I type here, I'm going to be in. So once again, it just shows you how you can subvert functionality or authentication. You can totally manipulate the application however you like at this point. So let's just go ahead and pull that back up. Let's pull the patched executable into Reflector. Now, here we can see in the decompile code up top, there is no if statement. We simply removed all of that code. So we jump from the try and the try catch block. There is no if statement. We go right into like, hey, show us, go ahead and show us whatever we type in, just give it to us. So we can verify that we actually removed that chunk of code as well. So and here I'm showing a screenshot of that missing code block. So just want to do a verification of that. So great success, right? Now we've successfully modified the application to subvert the authentication. Like I said, if we had obtained this executable from an end user or from somebody saying, hey, I've got this and I want to try and break in, how do I do it? What would be the best way to do it? Well, if it's a .NET application, your money, because you can open it up, modify the code, subvert functionality, subvert authentication, and get what you want. So hopefully you see how easy it is to control and modify .NET applications to your heart's content. Now, it's a little bit easier also to do deobfuscation. And deobfuscation is simply just finding a way to strip off the obfuscation to reveal plain text or clear text. If we can deobfuscate the obfuscated code, then we'll have a much easier time. Instead of, looking at gobbledygook, we'll actually have, all the functionality, all the variable names, all the class names that the developer intended. So not only will it allow us to follow the code from one class to another, from one code block to another, but it also may add easy context. So the applicant, the developer may say, hey, this is the check password box. All right, so things like that will add to make it easier to reverse. And then at that point, you're just really reading code, right? So that's the ultimate goal. Ultimate goal is to be able to just read code and figure out what it's doing. And luckily, Reflexel can deobfuscate many obfuscation tools. It's easy. All you do is right-click, Reflexel, obfuscator search. And next, Reflexel will try to determine the type of obfuscation used. Here it did. It found us. Hey, save as house. This is obfuscated with easy obfuscator. Would you like to deobfuscate it? And just click OK. Now, I have seen Reflexel what's not able to do every single obfuscator, but it has support for, I don't know, at least 10. It's crazy the amount of obfuscators it does support. And then next, you'll save the executable, and you can stick with the default start at clean extension. That way you don't accidentally overwrite the original. And once you do that, you can open that back up into Reflector and see where everything was cleaned up. Here's a look at the deobfuscated code. So now you see where it's basically, what the tool does is it sort of gives generic names. So you see it class 0, class 1, class 2, method 0, method 1, method 2. So sometimes it can pull out functionality, or sometimes it can pull out what the developer originally had there. Sometimes it can't. But you can see here in the if statement, it has if this dot field logon password. So that was the original variable that the developer gave it. Excuse me. And then you can go on down to the bottom where the else statement is and the message box.show statement, and now we see where the password incorrect and access denied. Now we clearly see that there. So it did a great job of doing that deobfuscation and showing the text that was there originally. So it's a great handy tool to be able to do this type of work. So it may not be able to retrieve, exactly everything the author or the developer originally had, but at least, it'll get rid of some of the garbage, make it a little bit cleaner to review. And in this case, like I said, we were able to see things like password incorrect and field log on. So those were some nice things it was able to do. And we could just do a quick demo of that. We can go ahead and get rid of this one and bring the original back in. Open the original back up. Just to prove. Here we still see, I'll go ahead and close Reflexel. Sorry. Now, Reflexel, obfuscated search, simply is obfuscated. Okay. Gonna replace my original. It says it was cleaned. We can come and get rid of this guy. Open up the cleaned. And now we're starting to see where things are starting getting named. Method 1, button 1. So they're seeing names associated with these. They're not seeing any more garbled strings here. So it's nice to see, these things getting flushed out. So once again, it just does a really nice job of, bringing in that strings that we couldn't see before. So once again, to review, the steps to reverse the .NET app. Number 1, run the application, understand the functionality. Probably the most important part. The other steps are just simply going through what you've already laid out in your head in step 1. Okay, figure out the functionality you want to reverse and go from there. Decompile the application. Go ahead and save that decompiled code to a text file and store that to the side. Maybe do some other searches within that as well. Number 3, review the source code and hone in on the functionality you're trying to understand. Here's where you're going to start doing some of your searching. You're going to search for those key constructs that we've mentioned in the past. If obfuscated, look for those key constructs and understand that functionality. And then lastly, if we've already kind of reversed it, figured out what it's doing, how can we modify it to get functionality we want out of the application? And this could be for legitimate purposes too. If a developer has left and the source code is not there, and it's just a binary, but then you can get that back out. Okay, or if the application doesn't do what you want it to do, simply modify it, and then all of a sudden you've got things as the way you want them. So wrapping up, a standalone .executable will more than likely be very easy to decompile and get original source code. Okay. I'm talking about obfuscation, but obfuscation is typically not used in applications. But obfuscation techniques only make it a little bit harder to figure out the original source code, right? But with tools like Reflexel and just reviewing constructs, you can easily decipher what the original functionality was of the application. So if you want to save your intellectual property, if you want to save all those hard nights and days coding, then don't write your software in .NET. Okay. for your standalone executables. It's kind of that simple. You know, if it's internal to your company or your organization and it's not going outside, then knock yourself out. And I'm not knocking .NET framework itself. It's actually a great platform to quickly stand up an application. I mean, it's very popular for a reason. So I mean, but just be aware that even if you do obfuscation and you think you've protected your hard work, it's not necessarily true. So that's it.